So following on from a 44 talk that I recently delivered with the VP of Spider Labs, Lawrence Monroe, I wanted to give you an overview of the Sheepl project, which is part of a project called LabSeed. LabSeed is really focused on trying to speed up the process of building unique, realistic lab environments for red team and blue team training, and Sheepl is a large component of that solution because it aims to add in realistic user behaviours that we can use to attack or defend. Sheepl itself relies heavily on an amazing solution called Autoit. Autoit is a freeware basic-like scripting language, and it's very powerful. It can interface with COM, it can interface with the kernel, it's very good at dealing with Windows GUI controls, and it can hook into the Windows API to access these solutions. It's very good at sending keys and controlling mouse movements. And as I started exploring this, I really realized that I'd got a great solution to emulating realistic user behavior. Another benefit is that once you've taken your output file, you can compile this into a standalone binary that doesn't require anything else on the box. So Sheepl is written in Python 3 and it generates valid Autoit language. And when I started thinking about what is it to be a user, I wanted to give them tasks that they would complete, things that we would expect to happen on a network, because a network is not just a connection of boxes that have no relationship. A network is generally a hive of activity, and that comes from the interaction between users. So Sheepl can create documents, Word documents, and save them in locations. They can interface with command line environments like CMD and PowerShell, and they can also browse internet internal structures using IE. You give them an amount of time to complete these tasks, and this can be anything from minutes to hours to days. And that's important. Time is a big factor in my thinking when I was developing this project, because I didn't want things to happen predictably. Over, say, every 10 minutes, I knew that something was going to happen. I really wanted to foster the principles of red teaming, blue teaming, being patient and trying to understand an event over a period of time. But I also wanted them to be a lot of randomness, and again, this is another principle of the project, is to introduce as much randomness as possible to really push back on that predictability. And finally, I wanted to be able to compile this into a binary that could be pushed around to other solutions, and Autoit is brilliant at this. First iterations of this project I was using Python, and I was compiling it using Py2exe, but when I started wanting to interface with Windows, I needed to bring in alternative third-party libraries, and it was really quite a pain to compile this all together into a simple solution. Autoit smashed that out, and it really made it the right solution for the goal of the project. So this is an example of the Sheepl output. It comes in two modes. You can pass it command line arguments, and this is really useful in building up complex characters on the command line that are en masse, essentially. And if I step through some of the switches here, you can see you have to give them a name and you have to give them an amount of time. This is from the 44con examples that we presented, so all of these time factors are truncated, in this case 1 minute. But as you can see, the first task is a Word file task, and what it's going to do, it's going to take the contents of the input.txt file, the letter.txt, and it's going to type that into a Word document. So the task itself will handle the instantiation of Word and the typing of the contents of the letter.txt. It will then save that in the path that's defined, in this case on the desktop as letter.doc. Then it has been assigned a second task, which is a cmd shell command, and it's going to interface with the shell command itself. It's going to issue those commands at random time intervals. So this kind of emulates user enumeration, I guess, troubleshooting to trying to find out an issue with the box. As you can see in the output below, there's a 40 millisecond delay there because you can control how fast they type, and that's really quite useful in thinking about how you can build in more realism, because in the real world users type at different speeds. And then when it's finished passing through all the tasks you've given it, the output of the file is 44con.au3. As you can see at the bottom that it's taken those and it's taken 3 tasks, and it's split the amount of time that you've supplied it up into 3 random millisecond intervals to splice in between when the tasks run in sequence. We've only supplied it 2 tasks, and that's because each sheeple starts its day with a tea break, like all good British workers do. And this is an output of the CMD interaction, and as you can see, it basically defines a function and it controls the invocation of how CMD starts. In this case, we're actually forcing to wait for the class control before it kicks in, and this is really good at making sure that you know where the input is that you're sending stuff to and where it ends up expected. Other solutions I've seen, sometimes it's easy for that to lose focus and for the things that you're trying to send end up somewhere else. So it removes that unpredictability of the content. And you can see it's going to type those commands in and it's going to have some random delays between them. And then ultimately it's going to exit out of that shell. And on the right hand side you can see the structure of the Sheepl class files. These are Python 3 class files that are objects in themselves, so you instantiate a task and then it has an entry point as to how it starts whatever task that you're doing, something that happens in the middle, and then an exit strategy. And this has been pivotal in how I've tried to design this moving forwards, because I want to continue to be able to add in more complex tasks, and this is just a case of writing the Python 3 file and then adding in the various options to invoke this throughout the program. So this is an example of the interacting mode, and this really works on a question and answer basis. So we're moving into this and you can see that there are some tasks there defined already. You start by creating the Sheepl name, in this case it's 44con interactive. And then, as I said before, an amount of time that you want that to the tasks that you assign to be achieved over. And I've just accepted the default of 40 milliseconds there for typing, but you can make differences in how people can type this. And then we've started a CMD shell as the first set of commands, and I'm just running through some of those examples that I placed in the first slide for arguments. And when I was looking at how I could achieve some of these things, I basically watched my own process, looking back at how I would interface with CMD and looking at the types of commands that I was typing, and then I would go back and I would build a Sheepl to represent that. So now once you finish that, you can add in another task through this question and answer. In this case we're starting PowerShell as an interaction. We're just calling getWMI on the Win32 service class, and we're just issuing some PowerShell version information to define CLI classes. As you can see there, I've sent another answer, so there is some context checking of responses to try and keep the flow through the program. And now the Sheepl, after it's done 2 pieces of work, it's going to use a tea break, and the tea break basically just adds a series of randomness into the overall solution, and it just sleeps for a period of time. And then after that's finished, they're going to open up IE and they're going to browse to Google using Internet Explorer. And this is really powerful when you want to sort of emulate users accessing intranet pages. Maybe you want to look at attacks where you're looking at cookie stealing, etc. They can actually authenticate to solutions as well. The classes need to be extended to do that, but as this is a beta version, we wanted to get the tool out there. But there's a lot of development now off the back of how we can extend these tasks to make them even more useful. There are also some other browser solutions that can be pulled in through third-party Autoit libraries. So really, at this point, I think the sky's the limit. And as you can see there, we've ended up, it's written a file, 44con interactive, and there's 5 tasks, and it's split the tasks up randomly. And once you take that file, you can use the program 8aut2exe, which is part of the Autoit solution. This is in a portable version, so you don't actually have to install this. I've also had some success running this with Wine as well. So there's various ways that you can take this file and you can compile it. In this case, I'm compiling it into an executable. I can specify whether I compile it for 64-bit systems, and you can specify the icons as well. Props to Jonathan Bennett for Autoit. It really is a very, very powerful solution, and I've turned into a massive Autoit fanboy. And what it looks like when you run it on the box. So we've started 44con in the context of a user, and you can see on the process tree on the left hand side that 44con.exe is now a child of Explorer, in the same way that you would expect any program invocation in the context of a user. And the first task was to run CMD. So when the when the Sheepl has started this, that also has become a child of Explorer.exe. So my point here is that it emulates how users actually start programs. You may have seen a quick flash there that netstat was created as a child of CMD itself. So in other words, it honours the process tree, which I think is a really interesting way to look at this from a user perspective. I've now just manually brought the Process Explorer window to the front to take focus, and that's to demonstrate that Autoit itself has some clever logic in that when it knows that it needs to issue a command to window focus, if it's not in focus, it will automatically snap it back. And that small detail has really been pivotal in making this a stable and functional solution for that. The fact that it knows that when it's interfacing with a window, if that window is not active, it will make it active. In that case, I'd minimized it, and it knew that it had to issue an exit command, so it brought it back up, maximized into focus so that it could gracefully exit that solution. It's now starting the second part of the tasks that we issued, which was the PowerShell invocation, just running getwmi on WinSys32, Win32 services, and now it's just running the PS version table stuff to enumerate the PowerShell version and the CLI runtimes, and then it will exit. At this point, it now moves into the tea break, which is the random part of the task list that we've given it, and you can stack these task lists up. So you can jump in and out as many CMDs as you want. You can chain them together. You just build it into a sequence. And now we're just waiting for the final task to come through, which should be to open up Internet Explorer and then browse to Google. Again, part of this, the fun of this, is that you don't actually know when any of this stuff is going to happen. And as you can see, that's loaded up Google via IE and browse to that site. So this is a more complex example of how this is how I use this and how I see that this is going to be useful. So I've extended the 44con binary to have more complex interactivity. Also, I've mistakenly misspelt netstat, so I've shown that we can backspace out of this typing, and that's going to be a feature that I'm going to implement where you can specify the typing ability of a user, and basically anything which is input can be based on an error threshold. So I think that makes it more realistic in how users interface, to add in the mistakes there as well, which ultimately makes it more complex for us. We're now waiting on a second task, which is to open up Word, and this is typing the context of a letter.txt, thanking 44con for allowing me to present this. And some of the headings and some of the font style changes have all been created by using hotkeys, because Autoit is clever enough to be able to register any Windows hotkey combination. It registers the Windows key itself and also Control Alt and Shift variations for modulating commands. And it will type, and basically anything that you add into Word can be emulated. So it's possible to insert pictures, hyperlinks. You could even potentially type macros. And then that's going to quickly save. It's overwritten the 44con thanks file that was originally on the desktop, but obviously you can put this in any location, so that could be a document saved to a network share, etc. They can also open existing documents that are there and continue to edit them. So I think that part of it really emulates how users work. So now I'm just launching PowerShell, but this time I've decided to launch it from CMD, and again I'm just giving you some hints to the backspacing I'm introducing. And this kind of emulates more sort of attacker focused approaches, so I'm going to start a bits transfer of just a benign text file that I have running on my web server that this is routable from. Again, nothing in the actual file itself, but I think you can see there that allows us to create realistic attacking behaviors. So basically anything that you can interface with PowerShell, anything you can type in PowerShell can be pushed through. Now I'm going to execute the MITRE attack T1063 example for when an attacker is looking to enumerate any security software that's installed on a system. And if you've got PowerShell script block logging on, from a blue team perspective this is great, because all of these commands are going to be registered in the PowerShell logs, and so this gives you great opportunities to be able to dig through them and look at what actual has been happening on the box to try to piece together maybe a blue team response. Now I'm going to show you that they can interface with RDP. You can make valid RDP connections with credentials, which is great for keylogging. Again, because all Sheepl type the commands that they're issuing, it brings into focus the opportunity for keylogging. In this instance, the remote desktop connection isn't going to go anywhere because I didn't have an internet connection when I was recording these slides. There's also some work around subtasking, so that basically anything that you create in an RDP session can be pushed over. And I've quickly opened up a Notepad solution there just to show that we've got some insecure credential storage in a Notepad file that could potentially be screenshots of or copied when it gets pushed to the clipboard. And as you can see below, I have the head request from the bits transfer from when we pulled down that toteslegit.txt file, and also we've captured some of those keystrokes. So I hope you've enjoyed that overview and you can see the power that Sheepl brings. The focus of Sheepl is really to try and emulate user behaviour. I want to be able to have things that are unpredictable, and I want to be able to build in that rich network traffic within an environment. There are other projects which are being released as part of LabSeed with the focus to try and make this a simple solution in supporting and building red team and blue team training environments. And personally, I found this very useful in understanding my tradecraft and the signatures of that tradecraft and how I can basically get better. This is a training tool for me, and I hope that people can see the value in using it as a training tool for them. My final point that I've said a few times is that anything that can be typed on a Windows keyboard can be emulated with a Sheepl. So essentially its ability is only really limited by your creativity and just thinking about how you would invoke a program, interact with it, and then how you can get the desired results. So I hope you've enjoyed that. Please keep a lookout on the GitHub for the 0.1 release of both this and a tool called User, which I'll do a separate screencast for. And I look forward to finding out how people are using this in their lab environments and to level up. Cheers, thanks very much.